Okay, so ladies and gents, for this next activity we're going to be introducing a new vocabulary word and a new type of angles. So we kind of were doing a little bit of these when we were talking about our alternate interiors, and it's going to be following that same basic concept of recognizing patterns amongst parallel lines and transversal lines, and then basically certain types of pairs of angles get a certain name. Is what it comes down to. So first, if again, I just have a sandwich plastic bag and a piece of paper, and that's all I have in here, and my dry erase marker. And let's go ahead and draw a set of parallel lines. Nice amount of space between them. Now with parallel lines, if these are lines, then they're going to have arrows that extend forever in either direction. That's the definition of lines. And then we're going to create our transversal. So if you remember, a transversal transfers and cuts through a set of parallel lines. How do we know these guys are parallel? Because I'm going to indicate by either a single, or in this case we're going to do a double set of what's are called chevrons. So whenever there's a matching pair of chevrons, that means that these two lines are parallel to each other. So it doesn't matter how I turn it, what it looks like, no matter what I do, if they have matching chevrons, then those lines are matching parallel lines. So then we have our transversal. So what you kind of notice here is that on this angle and this angle are acute angles. Remember, acute angles are less than 90 degrees. And here are obtuse angles, which are greater than 90 degrees. Same thing down here. I got two obtuse angles, two acute angles. So go ahead and take your second bag and lay it over the top of this one and trace one set of your lines. Got a little wiggle to it, but it will still work. Okay. So we have our lines that are set, and these two now are parallel and congruent to each other. Excuse me. So let's say this is, well, let's go ahead and use 70 degrees. Okay, well, if that's 70, then this one is 70 degrees. Now what I want you to do is I want you to go through all 8 of these angles. Technically one's already done. So we have 1, 2, 3, 4, 5, 6, and 7. And I want you to go through and find how many angles, and again I can slide, I can rotate, I can do whatever I need to do, and how many and which of these angles is equal and the same as 70 degrees. So which one, angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, or angle 7, how many of these and which ones are equal to 70 degrees? So go ahead and do that now. Right. So the question was, how many of these angles is equal to 70 degrees? So if we try, we're going to do a little bit of pivoting. If we line up these two angles, we could see angle 1 is not congruent to 70 degrees. And congruent means the same. If I come over here to angle 2 is the same measure as 70 degrees. So angle 2. So there's two angles so far that are equal to 70 degrees. And if we continue to pivot, and it doesn't matter which way I line it up, angle 3 is not congruent. Okay. So what about down here? So if I slide down here and spin and pivot, angle 5 is congruent. So I now have 3 angles. Angle 7 is not. Angle 6 is congruent. It is the same. And angle 4 is not. Okay. So if you also notice, one thing that makes it kind of nice is here is an acute angle. Number 1 is an obtuse angle. Well, number 2 was also an acute angle. Number 3 is not. Number 5 was an acute angle and also equal to 70 degrees. Number 4 is an obtuse angle. Number 6 was an acute angle and equal to 70 degrees. And number 7 was an obtuse angle, so it was not. So how many angles were congruent to 70? There were 4 angles congruent to 70. And those angles were angles 2, 6, and 5. Now, if you ever get stuck in trying to remember which one is angles, and so you're not spelling angels versus angles, just a fun little way that you can remember is that angels have perfect hair, and they have perfect hair. In order to have perfect hair, you have to have gel in your hair. So just a kind of a fun way is that there isn't any gel in angles, but there's gel in angels. Okay. So back over here, our question then says, okay, so number 2 and number 5, we had already talked about in previous videos, are called alternate interior angles. So if these are called alternate interior angles because they alternate across this transversal line and are within the set of parallel lines, then what do you think angle 70 degrees and 6 would be called? So if 2 and 5 are alternate interior angles, what would you call 70 and 6? Okay. So alternate exterior angles. Okay. And why do you think they'd be called alternate exterior angles? And I'll let you think about that. If these are alternate interior angles because they alternate across the transversal line, remember this is the transversal, and they are interior of the parallel, then why do you think these are called alternate exterior angles? So one thing that we learned before, that alternate interior angles are congruent, then what do you know about measure angle 6 and 70? Okay, so angle 70 and angle 6 are alternate exterior angle, and so thus they are also called congruent, which means they're going to be the same. So this is going to be 70 degrees. Alternate exterior angles. We discovered this is 70 degrees and this is 70 degrees. So the other question comes from, how many degrees is angle 1? And can we figure out these other missing angles here? Well, if we know a full line is 180 degrees, and this is 70, because they're supplementary angles, they add up to 180, that means angle 1 is 130 degrees. So given that angle 1 is 130, alternate exterior angle says that angle 7 is also going to be 130 degrees. Right? Well, if you look here, we have another supplementary angles, 70 out of 180, so this is 130. Well, these are alternate interior angles. So this is also going to be 130 degrees. So just by using supplementary angles, alternate interior angles, and alternate exterior angles, we were able to find all of these angles. So I want you to take a moment, and for this part, given we had something that looked like a transversal and a parallel lines, and this was, let's say, 50 degrees. Go ahead and find the measure of angle 1, 2, 3, 4, 5, 6, and 7. Given that these are parallel lines, can you use supplementary angles, alternate interior and alternate exterior, to figure out all 7 missing angles?